Hey Algebra 1, this is a help video where I'm going over 7.6, finding the x-intercepts of a parabola from vertex form. So again, the key words are x-intercepts and vertex form. Okay, so we're going to find the x-intercepts when the equation looks like this, when we have parentheses squared and then minus or plus some number. Okay, so what you want to do is, just like before, we're going to plug these numbers into the function in order to fill out the table. But we're not going to do number 1, so I want to actually skip down to number 3, and we're going to start here and practice this one. Okay, so what you'll notice is I actually have to change this. Let's not do that one. I want this to be y equals x plus 2 squared minus 8. And I think that's actually what it says on your worksheets. It doesn't say what it says on mine. Okay, so now I'm going to plug in these values into that equation. So let me bring up the calculator and plug it in just like you see it, right parentheses there. Negative 5 plus 2, and then you're going to hit the square button, minus 8. Okay, and as you can see, that in the calculator looks just like it does here. I plugged in that negative 5. And then the first number is going to be 1. Okay, actually let's reduce this down so I can see it. Or no, we'll just flip back and forth. Okay, so now, and let me make a couple adjustments to help me do this. Alright, so now we're going to do the same thing with the 4, or the negative 4. So we'll go up to the 4, up to the 5, change it to a 4. Now we have negative 4, okay, and then do the same thing with the negative 3, and you're basically going to do this for every single one of these values, okay, and I'll kind of pause it and let you do the rest. Now when you get to this point where you have negative 7 as your next value, you'll notice that it repeats. You'll see the negative 7 again, and then you know that with quadratics it repeats itself. Okay, so and remember, this is just for quadratic equations, not for any other type of functions. Okay, so now let's graph those points. Negative 5 and 1. And then negative 4 and minus 4. Negative 3, minus 7. So go down 7. And then negative 2 and negative 8. And negative 1 and negative 7. 0 and negative 4, and then let's see, what's the next one, and then 1 and 1. Okay, actually it looks like I'm a little off here. This should be negative 5 over here. Okay, so now make your parabola going off in both directions. It's kind of sloppy there. That's a little better. Alright, now the question is, why can we not find the x-intercepts from the parabola or the table? Well, if I look at the table, to find the x-intercepts I have to figure out what, I have to look for a point where the y is 0. And none of these points have y is 0. So I can't see the x-intercept there. And here at the table, here in the graph, that x-intercept is right here. And I'll highlight it. It's right there, and then there's another one there. Well, the problem is that it crosses between negative 5 and negative 4. So it's not an exact whole number. So it means it's like a decimal. But we can't just figure out what a decimal is by looking at the graph. So we have to use math to figure that out. So again, in the table, there is no y equal to 0. Okay, so let's figure out what that is by using algebra. And again, we're going to change this equation, so it'll be x plus 2 minus 8. So now that using algebra, what you do is first we want to set this equal to 0, just like we would solve equations before. So I'm actually going to bring this up here. So make it equal 0. So in other words, change that y so it's equal to 0. Now if you notice, I have parentheses squared here. This is a lot like when we used to do square roots, except we didn't have a number on this side, so we need to move that number. So now let's add the 8 to both sides. Now the 8's cancel out on the right. Now I have 8 equals x plus 2 squared. And if you remember, when the problem looks like this, I can take the square root of both sides. Square root here and square root here. And also remember, when you square root a number, like 8, it's going to have both a positive and negative result. So you have to put plus minus. And then when you square root parentheses that are squared, it's going to be x plus 2. Or when you square root two factors that are the same, you're only left with 1. Because remember, this is 2x plus 2's. Alright, now we're going to solve for x. So let's subtract 2 here, because it's plus 2. Okay, that goes away. And now our first answer is going to be x equals positive square root of 8 minus 2. And the next answer is going to be the negative square root of 8 minus 2. Now let's go ahead and figure out what that is on the calculator. Move it over here. Okay, let's bring this down. So again, square root of 8, square root of 8 minus 2. So that's going to be 0.828. Okay. And then let's do that for the negative square root of 8. Do the same thing, except let's put a negative in front now. And now it's negative 4.828. Oops, sorry. Okay, and there's your answer. So again, the key step was getting rid of this 8 and move it into this side, making it equal 0, or I should say make it equal 0, then we added the 8 to get rid of it, and then we took the square root. Okay. So now let's look at this problem here. So now we got to find the vertex and the x-intercepts of the parabola of this equation. Y equals 2x minus 3 squared minus 4. Okay, well let's first find the vertex. Remember the vertex, the x value is comes from the number inside the parentheses, and x is a liar, so that's negative 3. Then that's positive 3. And then the outside stays the same, the outside number, negative 4. So let's go ahead and graph that. And we're going to use these points to actually graph to kind of do a rough graph. So our vertex is at 3 and negative 4. And then we're going to draw a line of symmetry. So I'll use my pink color like I do in class. Remember, the line of symmetry goes right through the vertex. Okay. And then label it with the equation. And remember, it's just x equals, and then whatever that x value is that it runs through, which is 3. So x equals 3. Now we need to find the x-intercepts of the parabola and plot them. Well, now this is where we're going to solve the equation using algebra. So first, let's set it equal to 0. So 0 equals that same equation, 2 times x minus 3 squared minus 4. And the first thing we want to do, again, is add that 4 to both sides, just like we added the 8 in the last problem. That cancels out on the right. Now we have 4 is equal to 2 times x minus 3 squared. And now, this one's a little different because now we have a number in front of the parentheses. So to get rid of that, because in order to take the square root like we did up here, we can't have a number in front. All right, or we don't want to have a number in front. We could, but it just makes things more complicated. So to get rid of this 2, let's divide both sides by 2. Okay, that will cancel out these 2's. And then what you're left with is 4 divided by 2 on the left, which is 2. And then x minus 3 squared. Now I can take the square root of both sides. So square root. And again, if I square root a number, don't forget plus and minus the same number. square root this, I get x minus 3. And now I'll add the 3. That 3 goes away on the right side. Now my first answer will be the positive square root of 2 plus 3. And the second will be the negative square root of 2 plus 3. Now let's go ahead and find out what those values are in decimal, because ultimately we want to be able to graph these points, and I can't graph them if they're in a radical or a square root form, because I don't really know where that's at. So let's get a more closer exact value. So again, let's move this over a little bit. So the first number is going to be square root of 2 plus 3, and that's going to be 4.14. So that's the first value. Okay, the next one's going to be negative square root of 2. So negative square root of 2 plus 3. And that is going to be 1.58. And looks like that 7 is going to cause this 5 to go up 1. So 0.586. So 1.586. Okay, so let's graph those points. Remember, these are the x-intercepts that we just found, so graph them on the x-axis. So first the 4.14. What's a little bit more than 4, so it'll be like right in front of the 4. Oops, sorry. Like right there. Okay, and then the 1.586, well, it's about halfway between 1 and 2, so it'll be right there in the middle. And then we can kind of draw a rough graph with just those 2 points without actually making a table. And there's our graph. Okay? So that's how we did it. That's how we just graphed it without actually making the table. Okay? All right, well, that's it.